Really thick marker, don't even care. Okay, we have one common denominator plus 2, then we go a plus 2 in the top. Ahem. All right. They're the same. What happens? They cancel off. And what are these slanted lines that I do? They're just 1. So it's 1 over 1, which is 1. Good answer. Okay. 2, the non-permissible values. It's multiplication. We only care about those. We agree? If it was division, we care about the top right. It's not, so we don't care about it. So we have x minus 3 can't equal 0. X can't equal 3. I hope at the very least, even if you don't know how to solve for NPVs, you know there's 2 of them and you pick A. Right? I hope we can narrow that down. So we have 3x plus 1 can't equal 0. 3x can't equal negative 1. X can't equal negative a third. I don't know what just happened. A. Number 3, are those common? It's subtraction. When it's subtraction, we have to get common denominators. Are those common denominators? No. We have 3 over x minus 7 minus 5 over negative x plus 7 if we want to change the order. How do I make that be a positive x minus 7? Take out a negative 1. Let's try it out. If it doesn't work, I'm going to leave it. So we take out a negative 1. When we take a negative 1 out, this becomes a positive x and this becomes a negative 7. Now you can either multiply both sides by negative 1, or if it's just a negative 1, you can bring it to the top and distribute it in. And then you actually have common denominators. So this negative 1 I can bring up. So I can go 3 over x minus 7 minus, and I bring the negative up to the 5. Negative 5 over x minus 7. And then they're actually common denominators. And you don't have to multiply by negative 1. That only works if you take a negative 1 out. Now we have a common denominator. So we have, shocking that it's not working properly. Then we have a 3 minus a minus 5, so plus 5 over x minus 7, which is 8 over x minus 7. And x can't equal 7. So it would be A. The last one is a division. When it's a division, do we have to get common denominators? No. The only thing you get common denominators for are addition and subtraction and solving. Other than that, whether it's multiplication, division, or simplifying, we GCF difference of squares, all the numerators, all the denominators. So I'm going to get 20x minus 12 over x minus 3 divided by 5x minus 3 over 2x squared minus 18. First thing I'm going to do is flip the right-hand side and multiply. I'm trying to hold it together, but it's real hard. I'm just smiling, but I'm really angry. So I'm trying to make it better with a smile, but it's not working very well. Okay, so we have a 2x squared minus 18 over 5x minus 3. Then I go to every numerator and every denominator and see, can I take out a GCF or a difference of squares? The left one, I can take out a left numerator, I can take out a 4, and I'm left with x minus 3. The denominator, I have an x minus 3. The top, I can take out a 2, and I'm left with x squared minus 9. And the bottom right, I'm left with 5x minus 3. What's up with the x squared minus 9? The difference of squares. Remember I told you on the test, if you're not simplified to as low as possibly you can go, you're probably missing a difference of squares. What's up? Here? Where? Totally have that the whole time. I don't know what you're talking about. 5's been there. Didn't just slide in. It's fine. Did catch. I would have been stuck for a little. Okay. So then we have 4 over 5x minus 3 over x minus 3. Probably going to extend the page soon because it hates me. And then we get a 2. X squared minus 9 is x plus 3, x minus 3. And then on the right side, we have 5x minus 3. Our NPVs are for everything but the top left. So it would be, did you find your sheet? X can equal 3. I didn't know whose it was, but that's hilarious. It's just fun. X can equal 3, 3/5, and negative 3. Then you make a full numerator over a full denominator. The 5x minus 3's cancel, the x minus 3's cancel. Can the 4 and the 2 cancel? They're both in the numerator, so no. So a lot of you will give me the answer 8 plus 3, which is 11, which is wrong. Because we're going to go 8 bracket x plus 3. And people will say, well, that is 11 because it's in the form ax plus b. Holy moly, what is going on? Carry on. If people tell me this is A and this is B, is that true? Does this have brackets? No. The form they would have had to give you would have had to have been AX plus B. Did they give you that form? Nope. They gave you this form. So what do I have to do before I can do A plus B? Distribute. You have to make it in the same form they have. So it's AX plus 24, which is AB. 8 plus 24 is 32. Good answer. Good job. Thanks for all the help. So if you have the 4 boxes which are above, and I don't want to go there because I don't know what a board's going to do with me, you put the 3, then the 2. You always fill in left to right. If you fill in right to left, their little machine won't pick it up, even if it's the right answer. So it's left to right. Okay, we're going to go to the notes, page 15. I'm going to attempt. We're on page 15. So we're solving rationals. There are 2 types. There's cross multiplication and the common denominator one. But when I used to teach both types, I would lose everyone. So I'm just doing one. If you know the cross multiplication one, you can do it yourself. But I'm just sticking to one method. And it's the same method you would do with addition and subtraction. So on page 15. So it's saying solve. How do we know it says solve? Because it says the word solve. And there's an equal sign. Okay? Up until now, we've not done a solve. We've done all simplifies. There was simplify where there was just a basic rational. There was simplify where I made you multiply. There was simplify where I made you divide. There was simplify where I made you add. And there was simplify when I made you subtract, which just meant you had to put them together so that they were simpler, right? These ones with equal signs are solve. And whenever it says solve, it always wants variable equals number. That's what solve means. So in the end, I need to know what the heck x would be. For this one, you could kind of figure it out yourself just by mathematically figuring out how to make left side, right side. But we're going to solve it properly. So when we solve, it follows the same first step as addition and subtraction. What's the very first step of addition and subtraction? Make common denominators. So this one has an x plus 3 and this one has a 1. So I can just make them both be x plus 3, correct? So exact solving and adding and subtracting are all the exact same first step, common denominator. So I have 3 over x plus 3. Now I don't have an equal sign running down the left-hand side because there is an equal sign in it. You don't put an equal sign here and an equal sign here. You just run the equal sign where it is. And then 6 over 1. I'm going to multiply this one by x plus 3. So remember, just like addition and subtraction, I now distribute my numerators and collect like terms. Distribute my numerators and collect like terms. So I'm going to get 3 over x plus 3 equals 6x plus 18 over x plus 3. Once you have that written down, put your pencils down and just stare up. This is going to be the important part. It's not memorizing steps, it's understanding what you're going to do next. So the reason why we make common denominators with solving is, say I give you this, don't write this down, I'm just going to show you. say I give you 4 over x equals smiley face over x. What can you tell me about this, if that's a true statement? 4 equals smiley face, right? And why can you say that, Google? Yeah. So if this denominator is the same as this denominator, then what can I say? Its numerator is the same as this numerator, can't I? So I can just, people cancel off their denominators. You're not canceling off your denominators. You're just saying, if this is a true statement, if this denominator equals this one, my next step is to say, well, then 4 must equal smiley face. Right? I can just say that. I'm not, people are like cross them off. I'm like, why are you crossing them off? You're not actually crossing them off. You're using reasoning. If the denominators are the same, then the numerators have to be the same. That's your reasoning. So once you get your denominators to be the same, really hope my pen comes back. Once you get your denominators to be the same, so once this is the same as this, what can I say then? I'm really testing this board out right now. It probably is going to rebel against me. Then this here equals this here, right? True statement? So if the bottom's equal, then the top's equal. So once I have my bottoms equal, I can just set my tops equal to each other and solve. So the hardest part is done. But before I go and do that, what should I do? Because my denominators are going to go away. Say, yeah, NPVs. So my NPVs are going to be x can't equal -3. And the reason why I have NPVs is if my solution is my NPV, it's extraneous. All right. So once I have common denominators, I can set my numerators equal. So 3 equals 6x plus 18. Now I get people crossing off their denominators. Actually, crossing them off is not what you're doing here. That would be illegal math. You're not crossing them off. You're just saying, hey, if the denominators equal, now the numerators do. And now we're back to junior high solving. How do I get x by itself? Yep, subtract 18. So I get -15 equals 6x. Divide by 6. And x equals -5/2. If you want to check your reducing, what you can do is you can go -15 divided by 6 in your calculator. Everyone should try it out. -15 divided by 6. And then go math, enter, enter. Just math, enter, enter, and it reduces it for you. So you type in -15 divided by 6, then math, enter, enter. And it'll reduce it for you. You'll see -5/2. And then we have to follow behind with x can't equal -3. Has a denominator of x plus 3 and 4x plus 7. Are they anywhere alike? So what do you do? How do you make a common denominator with two binomials that have nothing in common? Times them by each other. It's exactly what you do. So try this one out. Okay. So we have x equals 2 and x can't equal -3 and -7/4. And then I told you grab out another piece of paper. Don't try and squish it on the one you're doing because we're going to use the quadratic formula. So we're going to do the question on the next page. Well, it's on the bottom of your page. It's on the next page for me. So this. I'm going to start it way up here because I'm not joking when I say I need extra paper. So this looks different than the other ones because the other ones I just had irrational equals irrational. We agree? What I could do to this one though first is add this whole rational over. So I would get 2x over x plus 2 equals, and I can add this whole thing over. So I get 5 over x plus 3. So I move the whole rational over. Now, what am I going to have to do? Get a common denominator. Is anything common between x plus 2 and x plus 3? No. So you just multiply them by each other. So we're going to multiply this side, left side by x plus 3. and the right side by x plus 2. My next step, distribute the numerators, keep the denominators. Uh-oh, what's happening? I'm getting a 2x squared plus 6x. So I'm getting an x squared. I haven't had an x squared yet. Five x plus 10. So now once again, I have denominator equals denominator, so I can set my numerator equal to my, oh gosh, I didn't change anything. Why did it do that? To my numerator. So now I have, I'm going to write it up here, 2x squared plus 6x equals 5x plus 10. Now it doesn't matter if you were in 20-2 or 20-1, you learned this last year. Doesn't matter if you're in 20-2 or 20-1, you learned this last year. Can you grab your formula sheet out if you have it near you? So on your formula sheet, on the very bottom left, you have a quadratic formula. If you forget to do if you forget what to do when you have a square, look at the bottom of your formula sheet on the left. It says I can use that quadratic formula for the form what? It says that can be used for ax squared plus bx plus c equals 0. It says you can only use that form, that quadratic formula, when you have it set equal to 0. You see how it says it? It tells you exactly what form you have to have. If you do not have it in that form, you cannot use that formula. They go hand in hand. So if you get an x squared and you're like, oh no, I forget what I have to do, go to your quadratic form, go to your formula at the bottom of the formula sheet, and it might give you a kick to be like, all right, I have to get it all to one side. Okay? Currently, this is not set equal to 0, right? And I need it to have 3 terms set equal to 0 in order to use that formula. That's what it told me on that formula sheet. So I'm going to subtract the 5x and subtract the 10 over. So this is all from grade 11. This is not grade 12 anymore. This is grade 11. So now we get 2x squared. We collect like terms. Minus 5x plus 6x is plus 1x. Minus 10 equals 0. And it says we can use this for the form ax squared plus bx plus c equals 0. We agree? Everyone agrees to that fact, right, Colton? Right, Adam? Okay. So we have ax squared plus bx plus c equals 0. So we line up what we have. So we have ax squared, bx, and then it's plus c. So what is my c actually? Negative 10. You have to take the sign with it, right? Now the quadratic formula states this. It says it's in the form x equals negative b plus or minus the square root of b squared minus 4ac. Now some people will say, do I get this? Is it on the formula sheet in front of you? Yeah. That formula sheet is the exact formula sheet, just not orange, on your diploma. It's the exact same sheet. Now, on that formula sheet, it shows that do you see this is going to be a numerator? This is an entire numerator. This line has to go the whole way. So those of you who draw the line halfway in or just under the squared or 3/4 of this length, that's not enough. The line has to start before the negative b, and it has to end after the square root symbol. Do you see how I did that? You don't need the dots on the end, but whatever. And then 2a is underneath. So make sure you have that. Okay, we're going to fill it into that formula, which you all learned last year. So let's fill in what we know. So we have x equals negative, whatever b is. B is 1. Plus or minus the square root of b squared. So I put it in brackets every single time. 1 squared. Remember how I told you I do stuff because then it won't make common errors go away if you do this? You need to put that in a bracket. Because if you don't put it in a bracket and it's negative, if you go negative, go do this in your calculator. Go negative 2 squared in your calculator. Not in brackets. Just negative 2 squared. Negative 2 squared in your calculator is going to tell you it's negative 4. Now put negative 2 in brackets squared. Negative 2 in brackets squared is 4, which is actually the correct answer. Correct? You were taught in grade 9 that if it's negative 2 squared, the 2 is only squared, but if it's negative 2 in brackets squared, then the negative 2 is squared, right? So if you want it squared, you put it in brackets. So I always put this in brackets. Minus 4 times a I put in brackets, which is a 2, times c I put in brackets, which is a negative 10, all over 2 times 2. 2 times a. And I go negative 1 plus or minus. You can type this whole thing in if you want, all at once, but you have to use the brackets like I told you. Now, every single person, just the square root. You can't type the whole thing in. There's no plus or minus button in your calculator, right? But you can type this whole square root in. So every single person is trying this, because there are tons of people who get this question wrong only because they don't know how to type it in properly. So type in square root, bracket 1, bracket squared, minus 4, bracket 2, bracket minus, or bracket minus negative 10. Oh my gosh, just type it in the way it is. I can't speak. Every person is typing it in. You should get 9. Because that's the square root of 81. Square root of 81 is 9. So you should put in square root, bracket 1, bracket squared, minus 4, bracket 2, bracket negative 10. And you should get 9. If you're not getting 9, you're doing something wrong. Are you getting 9? Everyone getting 9? No? Yeah, you just didn't use the square root. If you just go second root, second answer. So you do if the number isn't a perfect square. So if you get 9, it was a perfect square. But if, say, you got square root 41, then you would have to just put what's underneath the square root. Like if it's not a perfect square. If square root 81 is 9. So we can do it all at once. But, so we can go like this, right? Which is just negative 1 plus or minus 9 over 4. The catch here is the plus or minus splits. Can you guys pay attention? You need to show an x in front of each of them. People will just give me answers. Well, that's not x equals. It needs to be x equals. So this is going to split. I'm going to get one answer. That is x equals 1 plus 9 all over 4. And then I'm going to get one answer that is x equals 1. It's a negative 1, sorry. Negative 1 minus 9 all over 4. So this one gets me 8 over 4, which is 2. This one gets me negative 10 over 4, which is negative 5 over 2. So it splits. So my answers are x equals 2 and negative 5 halves. And what do I have to make sure I put behind this? X can't equal negative 2 and negative 3. Are either of my solutions that? Are either of my solutions negative 2 or negative 3? No, so they're good. Now remember, you can check every single one of your answers. All you would do is you would go to your original question here, and I'd plug 2 in for all of my x's and see if this equals 0. Or I plug negative 5 over 2 in for all my x's and see if I get it equal to 0. And if I do, then my answers were right. So you can check your answers always. And I'll do a little more checking tomorrow. We're going to skip example 2 and we're going to go to example 3 in your notes. You can go back to your notes. Yeah. quick way to type what in. And that was open bracket. No, that's not the bracket square. That's it. Everything's under the square. That's what we're talking about. So it's bracket. Bracket 2. Bracket. Okay. So we're here. I have 4 plus 2 over x equals 6 plus 3 over x. So this is 4 over 1. This is 6 over 1. It doesn't matter, excuse me, that you have more than one term. It matters that it's solving. If it's solving, what's my very first step always? Same as adding and subtracting. What's my very first step? Common denominator. So what's common to 1, x, 1, and x? Just 1 and x. Do I need to put a 1 though? Does the 1 matter? No. So I'm going to need to get them to all have a base of x. So I'm going to multiply this by x. That already has a base of x. Multiply this one by x. That one already has a base of x. So I'm going to get 4x over x plus 2 over x equals 6x over x plus 3 over x. This equal sign shouldn't be here, sorry. So, once I get a common denominator, I write both sides over one denominator. So I'm going to get 4x plus 2 over x equals 6x plus 3, bless you, over x. So I just have to do that extra step, just putting them together like addition and subtraction. So if you can't do addition and subtraction, solving is hard. Now I have this denominator equals this denominator. So I can say that this numerator must equal this numerator. So I'm going to have 4x plus 2. And you're going to learn to be excited when you don't see a squared. Why am I excited when I don't see a squared? Don't have to use quadratic formula. Right? You'll actually have no idea how excited you will be that you don't see a squared when you're solving. It makes life easier. I have an x on both sides, so I need to get the x's together. That's my first thing. Which one do I need to move? It does not matter. Pick one and move it. I'm going to move this one. I often move the smaller one. You could subtract the 6x. You'll still get the same answer. So I get 2 equals 2x plus 3. Then I subtract. Then I get annoyed. And then I subtract 3. So I get negative 1 equals 2x. And then I divide by 2. And x equals negative a half. What do I have to make sure I end with? The NPVs behind it, which is just x can't equal 0. Does my answer equal 0? No, I'm good. Now I could check this. I could take the, I'll bring this back down a second. I could put negative a half in for all the x's, and the left-hand side should equal the right-hand side. Correct? I can check these every single time. So in Google Classroom, I posted a homework page, and you need to do it. It's a couple questions from each thing. So there's a couple questions from equivalent rationals, simplifying, NPVs, multiplying, dividing, adding and subtracting, and solving. Okay? Because your test is when? Wednesday. Now I'm not going to give you a separate homework assignment unless you ask for extra questions or whatever on Tuesday night. So this one that I'm giving you for today has all the different types on it, right? So I don't need to give you another one tomorrow. If you wanted to do more tomorrow, I didn't give you every question from each section, so you could just do the alternator ones, right? So I posted it in Google Classroom. It's from the textbook, but I posted the textbook pages there too, and the answer keys. The answer keys are kind of gross because someone must have poured water on the one, the textbook. So it's like wavy looking on my little scan, but it's fine. It's not on the answer part. It's here, okay. So I get working on that. I will